Now we have seen how to find the inverse, or we have defined how to get the inverse. So there are two methods, one by using the row transformation, other by using the formula. So let us see, we will use the formula first and then we will go for row or column transformation. Now let us see an example. So we have, suppose this is a matrix. Now I want to calculate the inverse of this matrix. So if I want to calculate the inverse of this matrix, I need to calculate what is the determinant of this matrix, and then I need to calculate the adjoint of this matrix. So from the determinant we can identify whether the inverse exists or not, and if the inverse does not exist, then we will not able to calculate the inverse. But if determinant is not equal to 0, then definitely we will able to calculate the inverse and we can use the formula. So let us see the determinant of this matrix A. So we can have the determinant of A is equal to determinant of 1, minus 1, 0, 1, 2, minus 1, minus 1, 1 and 2. Now if I expand this along the first row, then I will be having 1 into, I will be having 1 into minor of this. So I will be having this is 2, minus 1, 1, 2, and now minus of minus 1, then I will be having minor for this one. So it is 1, minus 1, minus 1, 2, and now for this element 0, and I will be having minor, that is going to be 1, 2, minus 1, 1. Now let us see, so this is going to be minus, this is going to be 1 into, the product of these two is going to be 4, and minus, the product of this is minus 1. Then minus, this minus minus will become plus 1, and you will be having the product of these two 2, and the product of these two, so it is going to be 1. Now this is being 0 into the minor, it will be 0. So we get here, this is going to be 4 minus minus will become plus 1, 5 plus you will be having here, this is 2 minus 1. So you can have 5 plus 1, and that is going to be 6. So determinant of A is equal to 6, which is not equal to 0, and hence we can say A inverse exists. Because this matrix, whatever we have considered now, here we are getting that the determinant of A is not equal to 0, is going to be 6, and it is a non-singular matrix. So we can have the inverse of this matrix. Now if I want to calculate the inverse of this matrix, then I need to calculate the cofactors of all elements, and then we can have the cofactor matrix. Then we will take the transpose of this cofactor matrix and we can get the adjoint of this matrix. So first let us calculate the cofactors of all element. So if I consider for the first element 1, 1, then the cofactor of this is going to be minus 1 raised to 1 plus 1, and the minor, so you will be having here 2 minus 1, 1, 2. So this is what you will be getting, minus 1 raised to 2 is going to be 1, and hence this is going to be 4 minus of minus 1, so that is going to be 5. This minus minus will become plus, and hence you will be having 4 plus 1 is 5. Now we calculate for A 1, 2. So this is minus 1 raised to 1 plus 2, and the minor. For this element we have to eliminate the second column and first row. So you will be having 1 minus 1, and it's going to be minus 1, 2. Now this minus 1 raised to, I will be having minus 1 raised to 1 plus 2, that is going to be 3. So minus 1 raised to 3 is going to be minus, and for this I will be having, this is 2 minus, this will be 1. So we get here, this is going to be 1, and with this minus sign we will be having minus 1. Now we can have A 1, 3. So for this I will be having minus 1 raised to 1 plus 3, and minor of this element. So we can have, we have to eliminate the third column and first row. So if I delete for this element third column and first row, then we have the minor 1 minus 1, and you will be having 2, 1. So here minus 1 raised to 4 is going to be 1, this is going to be 1, and minus of minus 2, so it is going to be 3. Now we consider the second row, so the element A 2, 1, this element, and now what we will be having, minus 1 raised to 2 plus 1, and minor of this element. So I will be having minus 1, 1, and 0, 2. So minus 1 raised to 3 is going to be minus 1, and then this is going to be minus 2, this element minus 0. So this minus 2 minus is going to be 2. and hence you will be having A 2 2. The next element minus 1 raised to 2 plus 2 and minor of this element. So it is going to be 1 0 and you will be having minus 1 2. Now we consider minus 1 raised to 4 is going to be 1 and this element 1 into 2 is going to be 2 and minus 0. So it is 2. Now we consider A 2 3. So second row and the third element, this element, so we have to consider minus 1 raised to 2 plus 3 and the determinant. For this element we have to omit the second row and third column. So we will be having 1 minus 1 and minus 1 plus 1. So here minus 1 raised to 5 is going to be minus and this element is going to be 1. This is going to be minus 1, so it is going to be 0. Now for the third row and first element, this element we have to consider and hence minus 1 raised to 3 plus 1 and the minor. So we have minor for this element is minus 1 0 and it is 2 minus 1. So minus 1 raised to 4 is going to be plus 1, then this element minus 1 into minus 1 is 1 and minus 0, so it is going to be 1. Now you will be having for the element A 3 2. So for this element we want to consider now the minus 1 raised to 3 plus 2 and now we have to consider the minor of this element. So minor for this element is 1 1 and you will be having 0 minus 1. So we get here this minus 1 raised to 3 plus 2 5, minus 1 raised to 5 is going to be minus 1. So this minus and then the product of this is going to be minus 1 minus 0. So this minus 1 and this minus sign will have plus 1. Now we need to consider for A 3 3. So it is minus 1 raised to 3 plus 3 and minor of this element. So you will be having 1 1 and we have minus 1 2. Now minus 1 raised to 6 is going to be 1. So here this is going to be 2 minus of minus 1. So 2 minus minus will become plus and you will be having 2 plus 1 is 3. So this way we have calculated all the cofactors for all these elements of matrix A. Now we need to write the cofactor matrix for this matrix A. So consider this cofactors. So we can write the matrix of cofactor as A cofactor. And now what we have the elements are 5 minus 1 3 then 2 2 and 0 and you will be having 1 1 and 3. So this is the matrix of cofactors. This is the cofactor matrix. Then we can define adjoint of A. Adjoint of A is cofactor and its transpose. So when we take the transpose, rows will become columns and columns will become row. So this row will become column. So 5 minus 1 3. This row will become column. So 2 2 0. This row will become column and you will be having 1 1 3. So we got the adjoint of A. Now we can define the inverse of matrix A. So we have A inverse is equal to 1 upon determinant of A into adjoint of A. So we have already calculated the determinant is 6. So we will be having 1 by 6 and this matrix adjoint. So we got 5 2 1 minus 1 2 1 and 3 0 3. So we got A inverse is equal to 1 by 6 times 5 2 1 minus 1 2 1 and 3 0 3. So this way by using the formula A inverse is equal to 1 upon determinant of A into adjoint of A, we are able to calculate the inverse of this matrix.